Just a moment. Okay. Do you see my screen?
Yes, sir.
Yes, sir.
Okay. So first example
Yes, sir.
is in electrical circuit. So in electrical circuit, you have to determine voltages and currents at various locations in resistor circuit. So these problems are solved using Kirchhoff's current and voltage rules. The current rule states that the algebraic sum of all the currents entering to a node must be equals to zero. Okay, where the current which is entering the node will be positive sign, current leaving the node will be negative sign. And what is Kirchhoff's voltage rule? It specifies that the algebraic sum of potential differences in any loop must be equals to zero. So these are known to you. So these two rules you have to apply on a resistor circuit, and you will have to determine the current and voltages at various points in the circuit. So once such circuit is given by this, so let us quickly draw. I am not going to solve the example in details. Okay, so here is one such circuit. This is the source. This is V1. This is 200 volt. Then one resistor is there. Then here one node. Another resistor will be there. Then another resistor is there here. One more resistor is there in between these 2 points. One more resistor is there. And here. So this is the diagram. So this is V1, V2, V3, V4, V5, V6. V6 is given 0 volt. Okay. Now resistors are given as, so these let me name these nodes. Nodes are, you can give anything, 1, 2, 3, 4, 5 and 6. The names are given as this. Here it is R equals to 5 ohm. Here it is R equals to 10 ohm. Here R equals to 10 ohm. Here R equals to 5 ohm. Here R equals to 15 ohm. And here R equals to 20 ohm. So what will be the current flowing in loop 1? I do not know the direction. No harm is there if you consider any arbitrary direction of the current, and if you are getting a negative number at the end, then it was wrong. So direction will be opposite of whatever you have considered. So you consider some current through each resistor, and then you use Kirchhoff's current rule and voltage rule. So how many nodes are there? Tell me. So you see, no, four loops are there. Four nodes are there. This one I am denoting them by dots, black dots. So four nodes are there. So there you will get four equation. Huh? So you assume the current through each register. So you consider according to their node number. So suppose this is here I12, this is I23, then I34, I45, and here I25, I25, and here it will be R56. Sorry, not I56. So you will get four equation using Kirchhoff's current law. So they will be here in node 2. The equation will, what will be the equation? You assume this is the direction of the current. This is the direction of the current. Any direction you can assume. It is not like you have to consider this. You can consider opposite of the direction. You can change the direction of the current at any arbitrary register, and then answer will be coming negative. It is coming negative. If it is coming negative, then you should have considered opposite of that. So here, if you consider this, then from node 2 you will be getting I12 is entering, then who are leaving according to the node, according to the arrow, I23 is leaving. So minus I23, and according to the picture, I25 is entering. I have given the convention like that. So here is shown is at line you will get I25 negative. So opposite of this will be the correct direction of the current. Anyway, so let us add it here. I25, that will be equals to 0. Then you will be getting I23 minus I34. I23 minus I34 will be equals to 0. Then I45, I45, oh, I45 is leaving. So it will be a minus sign, plus I34 is entering. So that will be equals to 0. And here at node 5, you will be getting I45 minus I25 minus I56 equals to 0. So these are the four equations you are getting from Kirchhoff's current rule and from Kirchhoff's voltage rule. How many loops are there? How many loops are there? Two loops. One is this loop. Let me highlight them, the loops. One is this loop and another is this loop. So two loops are there. So there you apply Kirchhoff's voltage rule. There you will get two equation. So two equation from there and four equation from here. You are getting six equations. And how many unknowns are there? Unknowns are six. The currents I have denoted. So six equations, six unknowns. You can solve them. Now, if the circuit is bit complicated, then it will be a bit difficult to solve the currents and voltages at various locations manually. So you will have to take the help of some sort of program or computer. Okay. So this is one such example where you need to solve system of linear equation. Another example you can encounter two more equations to be coming. Two more equations will be coming from Kirchhoff's voltage rule. Okay. Another equation, if you consider this mass spring system. So suppose you are given a mass spring system in this way. So this is the floor here. This is the ceiling. This is the ceiling. From there, one spring is attached. At the end of the spring, mass M1 is hanging. From M1, two more springs are attached. Okay. And here mass M2 is hanging. And one more mass is attached, suppose here. So by a spring. M3. So This is in equilibrium position when the length of the springs are in equilibrium. Springs are in equilibrium. Now, once you let them hanging under the gravitational pull, how much the spring? So suppose the first spring I'm calling spring 1, then how much the masses M1 and M2 will be displaced, M1, M2 and M3 under the gravitational pull. So if this is the scenario in equilibrium position, and if you let them hang under gravitational pull, how much displacement will be for M1, how much displacement will be for M2, and how much displacement will be for M3, provided each spring having same spring constant K. Suppose for simplicity, each spring is having same spring constant. So what you have to do? If you suddenly release them, they will start oscillating. So they will be satisfying some kind of differential equation. Now, once again, when they will reach to the equilibrium under the gravitational pull, then each of the masses will be displaced from its original position. So you will have to first consider the differential equation, and when it will reach to equilibrium, the derivative involved in the differential equation will be zero. So you will get a system of linear equations. So how you are getting? So can you tell me what will be the equation of motion for mass m1? So suppose at any given moment, let me draw the picture. So this is the equilibrium position of the mass m1, and after gravitational pull, suppose the position of mass m1 is this. So this much distance, suppose that much distance is x1. So x1 distance will be mass m1 will be displaced. Okay. Then two springs are there. Okay. So this is the equilibrium position for mass m2. So mass m2 will be displaced. So suppose this is m2. Suppose this is x2 amount. Now mass m2 is not displaced exactly x2 amount. It will be x2 minus x1 amount, because local coordinates are used. And suppose this is the equilibrium position for mass m3. So at any given moment, suppose this is the position of m3. So mass m3 will be displaced this much amount, x3. So pure displacement for only mass m3 will be x3 minus x2. So these are the things you have to keep it in your mind. Now I formulate the differential equation for each of these masses m1, m2 and m3. So can you tell me what will be the differential equation for m1? Use Newton's second law. So m into, what is the differential equation of m1? So m1 into d2 x1 by dt2 will be equals to, how many forces are pulling them? How many forces are pulling m1? Two springs are pulling downward, so there will be positive sign. Spring constant is x, and springs are displaced how much amount? x2 minus x1 amount. So 2 into k into x2 minus x1, and one gravitational pull will be there. So m1 into g, and one upward pull is there. So minus k x1. So this is the equation of motion for mass m1. What will be the equation of motion for mass m2? Two upward pull is there, one downward pull is there, and one more downward pull is there due to gravitational law. So you will be getting m2 into d2x2 by dt2 will be equals to k into x3 minus x2 plus 2k x2 minus x1. Upward will be minus, sorry. So it will be minus and plus gravitational pull m2 g. What will be the differential equation for the last mass m3? Can you tell me? Can you tell me? Gravitational force is pulling downwards and spring will be pulling upward. So you will be getting, tell me what you will be getting? M3 into d2 x3 by dt2, that will be equals to minus k times x3 minus x2, pure displacement for mass m3. Okay, so that is upward pull minus plus is gravitational pull, so m3g. So these are the three differential equations you are getting, system of differential equation in x1, x2 and x3. So if you want to know what is x1, x2, x3 with respect to the time t, you have to solve these simultaneous differential equations. Now when the system will reach again in equilibrium position, what will happen then? The motion will not be there. So you will be, these differentials will be zero. Second order derivatives will be zero. So from there you will get right hand side equals to 0. From there you will get right hand side equals to 0. Each of the equation on the right hand side, each of the expression on the right side, they will be 0. So basically what you are getting? You are getting three equations with three unknowns x1, x2 and x3. And they are linear. So basically you are ending up with linear system of equation. So you will have to solve them to get the values of x1, x2 and x3. Okay. So these are the few instances you will be encountering system of linear equations. There are several other applications. I will not be able to show you all of them, and you have already applied that idea, solving system of linear equation many times. So here we are going to discuss few techniques. So first one will be, I have already mentioned, LU decomposition method. LU decomposition. So what is that? So first you have to write down the given system of equation in matrix form. So try it. So here you see I had written the given system of equation in matrix form. So these are the given system of equations: a1 1x1 plus a1 2x2 so on up to a1 and xn equals to b1, first equation. And in this way you go up to the last equation, an 1x1 plus an 2x2 up to an and xn equals to bn. So there are n equations with n unknowns. You write down that in matrix form. X equals to b. A will be the coefficient matrix, x will be the unknown vector, and b is the right hand side constants. So you take them in a column and create the column vector b. Okay. So we assume that the system has unique solution. Then how to find out the solution in LU decomposition method? So suppose the system of equation is, let a into x equals to b be the given system of equations. Okay. So A is a n cross n matrix. X is n cross 1 column vector. B is n cross 1 column vectors. There are n equations with n unknowns. Now what we are going to do in LU decomposition method, we are going to write A as L into U. What is L? L will be lower triangular matrix. L will be lower triangular matrix, and U is upper triangular matrix. Okay. Now How do you know that we will be able to write down A as L into U? It is not every time possible. It is not every time possible. So for every system, it is not possible. So when will be possible to decompose A as L into U? So it is possible. It is always possible. So sufficient condition for such decomposition is if the matrix is positive definite. Sufficient condition for such decomposition is the matrix should be that the matrix should be positive definite. Can you tell me when the matrix will be positive definite? We discussed it. You have studied it in second semester. Can you tell me what are the conditions for a matrix to be positive definite? Anybody? A matrix will be positive definite if its all principal minors are greater than 0. जो प्रिंसिपल माइनर्स होंगे वो सारे ग्रेटर देन 0 होने होंगे, या आप आइगन वैल्यूज से भी पॉजिटिव डेफिनेटनेस चेक कर सकते हैं. ऑल द आइगन वैल्यूज ऑफ द मैट्रिक्स शुड बी ग्रेटर देन 0. इफ any of the two conditions are satisfied, either all principal minors are greater than 0 or all the eigen values are greater than 0, that will imply the matrix A is positive definite. And once the matrix A is positive definite, you can write A as product of lower triangular matrix and upper triangular matrix. Okay, so if you write A as L into U, then what will happen to the system A? The given system Ax equals to B will be, then A will be Ax equals to B will be Ax equals to B will be A is L into U. A is L into U into X equals to B. So from there you are getting, suppose you put something. So put U X equals to, let's say, Z or Y. Ux equals to, that will be some column vector U into X. So suppose that is equals to Y. So if you use this substitution here, you will get Ly equals to B. Suppose Y equals to column vector Y1, Y2, Y3 up to Yn. Okay. So Ly equals to B you are getting once. So this is what? This is what? Lower triangular system. Lower triangular system. And how to solve lower triangular system? By forward substitution. Let me show you. We solved, we discussed. You see, by forward substitution you can solve lower triangular system. Okay, so if this kind of systems are there, you can easily solve. In first part, all the unknowns are directly solved. In the second part, here in the second part, you have to start with the last equation, calculate x3, then use the value of x3 in the second equation, solve for x2, and use the values of x2 and x3 in the first equation to get x1. So you are doing backward substitution. Here in the last system of equation, you are using forward substitution. You will be solving the last equation, first equation first, Then using that, you will be solving second equation. Using the first two values, you will be solving the last equation. So if you have a lower triangular system or upper triangular system, you can easily solve. So here Ly equals to B, that is what? That is a lower triangular system. So lower triangular system can be easily solved using forward substitution. So usko solve karo. Once the value of y, the column vector y is known to you, now you solve. Now solve ux equals to y, because y is known to you now. So ux equals to y will be upper triangular system. Okay, so it is upper triangular system. So upper triangular system can be solved using backward substitution. So do it and find out the values of x column vector, unknown column vector of the original system. So this is the main idea in LU decomposition method. So how to decompose A as L into U? So let us see that first. Now this idea can be used to find out the inverse of a given matrix if it exists. What A is what? A is equals to L into U. So what will be A inverse? A inverse will be U inverse, L inverse. Now finding inverse of an arbitrary matrix is not an easy job, but finding inverse of a upper triangular matrix and lower triangular matrix, they are relatively easy. Finding inverse of a given matrix, arbitrary matrix, is not an easy job if the dimension is large. But if the matrix is upper triangular or lower triangular, their inverse can be found very easily. So that is why if you know U inverse and L inverse, using that you can find out A inverse. So this is also used to find out inverse of a matrix, and so that is the idea. So let us see how to decompose A as L into U. So suppose we are considering 3 cross 3 matrix A, which is positive definite. Okay. So A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is the matrix A. So that will be equals to some lower triangular matrix into some upper triangular matrix. So let me write down lower triangular matrix. Suppose this is L11 0 0, L21 0, sorry, L21, L22 0, L31, L32, L33. So first matrix I have written, that is lower triangular matrix. Now you have to consider upper triangular matrix. So suppose that is U11, U12, U13, then 0, U22, U23, 0, 0, U33. So now if you do the multiplication, if you complete the multiplication on the right hand side and equate the two matrix component wise, element wise, how many equations you are getting? Remember A1, 1, A1, 2, A1, 3, this left hand side matrix will be known to you. Right hand side, lower triangular and upper triangular matrices are unknown. So how many unknowns are there on the right hand side? Altogether? Students, are you listening?
Yes, sir.
Tell me how many unknowns are there on the right hand side? in lower triangular matrix, how many unknowns are there?
6.
And in upper triangular matrix, how many unknowns are there?
6.
So altogether total 12 unknowns. But left hand side you have 9 values. So if you compare two matrices, left hand side and right hand side, you will get 12 unknowns with 9 equations. So that had infinitely many solutions. So the decomposition will not be unique. Decomposition will not be unique. So here for unique decomposition, you will have to consider certain values. So these are the values which are usually considered for unique decomposition. So for unique decomposition, if unknowns are more, then the system will always have infinitely many solutions. Okay. So here if so either you will be considering LII, the diagonal elements in lower triangular system, that will be considering 1 each element in the lower triangular matrix in the diagonal position. Either they will be 1 for unique decomposition. So let me write down for unique decomposition, LII will be 1 for all I. If it is LII is considered to be 1, then this method is known as Dolitt's method. DOOLLI, DOOLI, TTT, just a moment, double T LE method. And if you consider diagonal elements of the upper triangular matrix, if UII equals to 1 for all I, only one of them will be 1. Either LII will be 1 or UII will be 1. Then this method is known as Crout's method. CROUTS, Crout's method. Okay. So you can consider any of the diagonal of upper triangular or lower triangular as unit. Okay. So suppose we are considering LII equals to 1. Then what will happen? Suppose LII equals to 1. Then you will get left hand side A11, A12, A13, A21, A22, A23, A31, A32, A33 will be equals to 1, 0, 0, L21, 1, 0, L31, L32, 0, not 0, it will be 1. 1 into U11, U12, U13, then 0, U23, U22, U22, U23, 0, 0, U33. So now you do the multiplication and you compare the elements of two matrices on the left hand side and right hand side, you will get 9 equations with 9 unknowns. So you can solve them, and these systems are very easy to solve. Once the matrix is positive definite and you consider the decomposition of A as L into U in this form, this decomposition is very easy. It can be easily solved. Manually it will take some time, but in computer it will not take any time. It is very easy to solve, because if you do the multiplication, first you have to solve fast. So when you will be solving, you get 9 equation for 3 cross 3 matrix. Okay, you will get 9 equation with 9 unknowns. So when you will be solving that system of equation, first you will have to solve for, so in a systematic way you have to solve. First look for first column of L, solve for first column of L, then you will be solving for first row of U, then you will be solving second column of L, then you will be solving for second row of U. You got the idea. First column of L, first row of U, second column of L, second row of U, third column of L, third row of U, and so on, depending on the dimension of the matrix. Okay, let us see how you can easily solve. Let us see how. So if you compare, if you do the multiplication, can you tell me what are the equations you are getting? So let me write down. So take one particular example and let us try to decompose that. Okay, so let us discuss this with an example and see how we are decomposing the matrix as L into U. So here I want to solve this system of equation. 4x1 plus x2 plus x3 equals to 4. One equation is given. Next equation is x1 plus 4x2 minus 2x3 equals to 4. Just a moment. Hello. Okay, আমি কি করে এখন পয়সাটা দেব? আমি তো অফিসে আছি। Just a moment, students.
नाम क्या बोला?
Hello, students. Hello, students. Am I audible?
Yes, sir.
Yes, sir.
Okay. So the system, let me complete the system. 4x1 plus x2 plus x3 equals to 4. 1 plus 4x2 minus 2x3 equals to 4. 3x1 plus 2x2 minus 4x3 equals to 6. So here if you write down the matrix, the system of equation in matrix form, it will be of the form Ax equals to B. What will be A? A will be 4, 1, 1, 1, 4, minus 2, 3, 2, minus 4. Okay, 4, 1, 1, 1, 4 minus 2, 3, 2 minus 4. What will be X? X is column vector of unknowns, x1, x2, x3. What will be B? Right hand side में जो वैल्यूज हैं वो सारे वैल्यूज लेके जो आप वेक्टर बनाएंगे. So 4, 4, 6. So before you solve it by this system, by LU decomposition method, You have to decompose the matrix as L into U form. Okay. So let us suppose 4 1 1 1 4 minus 2 3 2 minus 4 is equals to, tell me what is the general form of U, L and general form of U. Suppose I am considering diagonal elements of L equals to 1. So it is L, it is 1 0 0 1 0 0, L2 1 1 0, L3 1 L3 1, and it will be U11 U12 U13. Just a moment. Then it will be 0 L U21 U22 general, it will be U22 first, U22 U23 0 0 U33. So now you do the multiplication and see what is happening. So this will be equals to, if you do the multiplication, tell me what it will be. U11, what is the next element, second element in first row? Tell me. Tell me. U12 U13. Then what is the first element in second row?
L21 U11.
L21 U11. Then next element, second element in second row,
L21
L21
U12
U12
plus
plus
U22.
U22, and you got the idea. You complete it. So let me write down for you first. So here it will be U13, and here what is the third element in second row? L21 U13. Next, tell me. L21 into L23. L21 into L23 plus U. You are not telling. L21 into L13 plus U23. Okay. Then third row, that will be L31 U13, L31 U13, then L31 U12, L31 U12 plus L32 U22, L32 U22, and the last element will be L31 U13 plus L32 U23 plus U33. So the technique what I said, that will be used if the diagonals of U matrix is 1. So this technique will be used. So let me write down here. This technique will be used. Opposite of that. So this technique will be used. This technique will be used if diagonal of U is 1, और अगर if diagonal of L is 1 तो पहले आप फर्स्ट यू मैट्रिक्स के फर्स्ट रो को सॉल्व करेंगे, उसके बाद एल मैट्रिक्स के फर्स्ट कॉलम को सॉल्व करेंगे, उसकी जो ऑर्डर है वो चेंज हो जाएंगे, पहले यू को सॉल्व करेंगे उसके बाद एल को सॉल्व करेंगे. ओके, सो हियर you have to solve for first row of U, then first column of L, then second row of U, then second column of L. That you will have to do. So if you compare two matrices, first and last, what you are getting? What is U11? Tell me. U11 is 4, U12 equals to 1, U13 equals to 1. Okay, U11 equals to 4, U12 equals to 1, U13 equals to 1. So first row of U matrix is obtained. Next will be first column of L matrix. तो कौन से एलिमेंट को कंपेयर करेंगे? फर्स्ट कॉलम ऑफ एल मैट्रिक्स. तो फर्स्ट कॉलम ऑफ एल मैट्रिक्स में एलिमेंट कौन से हैं? L21, L31. फर्स्ट कॉलम ऑफ एल मैट्रिक्स में कौन कौन एलिमेंट है? L21 एंड L31. सो L21 को फाइंड करने के लिए किसको सॉल्व करने हैं? ये जो हाईलाइटेड जो एलिमेंट है इनको कंपेयर करके सॉल्व करने हैं. इसको 1 के साथ कंपेयर कीजिए एंड टेल मी व्हाट इज L21. What is L21? What is L21, students?
One by four. Four.
U11. So that is 1 by 4. Then किसको सॉल्व करेंगे? नेक्स्ट एलिमेंट इन फर्स्ट कॉलम. तो नेक्स्ट एलिमेंट इन फर्स्ट कॉलम क्या है? L31. सो L31 को किसके साथ कंपेयर करेंगे? 3 के साथ. तो क्या मिलेगा आपको? व्हाट विल बी L31?
3.
L31 will be 3 by U13. So what is U13? 1. So 3 by 1 equals to 1.
So there U13 is not there. U11 is there.
Where U11 is there?
Sir, third row, first column.
Third row, first column. L31 into
U11.
L31 into U11 आएंगे. ओके, हाँ, L31 into U11 आएंगे. हाँ, यहाँ पे एक मिस्टेक था. L31 into U11. So it will be U11. You have to do the multiplication in correct way. I made mistake there. So it will be U11. So what is L31 then? 3 by 4. So it will be 3 by 4. Okay. So first row of U, then first column of U, then you will have to solve for second row of U. So what will be second row of U? So second row of U में कौन कौन है? U22 and U23. So U22 को अगर सॉल्व करने हैं तो आपको ये दोनों एलिमेंट्स को कंपेयर करने होंगे. ये जो मिडिल में जो एलिमेंट है. So what will be U22? So here it is first row of U, it is first column of L, then we will be solving for second row of U. So what will be U22? U22 will be 4 minus L21 into U12. So 4 minus, what is L21? 1 by 4, U12, 1. So 4 minus 1 by 4, that will be 15 by 4. 15 by 4. And what will be next element? U23. So U23 को सॉल्व करने के लिए आपको ये दोनों एलिमेंट्स कंपेयर करने होंगे, दिस -2 with this. So U23 will be -2 minus L21 into U13. So that will be equals to -2 minus L21 कितने हैं? 1 by 4 है, और U13 कितने हैं? U13 1. So it will be 2 minus -2 minus 1 by 4. So it will be minus 9 by 4. Minus 9 by 4. So this is what? This was second row of U. आप किसको आपको सॉल्व करने हैं? सेकंड कॉलम ऑफ एल. तो सेकंड कॉलम ऑफ एल को सॉल्व करने के लिए आपको क्या करने होंगे? सेकंड कॉलम ऑफ एल में कौन है? L32 है. So if you want to solve L32, you will have to solve, you have to compare these elements, this element and here 2. So 2 will be equals to L31 U12 plus L32 U22. From there you solve for L32 equals to something. So that will be second row of second column of L. Okay, and at the end you have to compare these two underlined elements to get U33. That will be, so -4 will be equals to L31 U13 plus L32 U23 plus U33. So solve it. To get third row of U. Third row of U. So this is how you are solving to find out the decomposition of A as L into U. Now, if you consider the diagonal of U matrix to be 1, then you will have to solve in this way. You will be solving for first column of L, then first row of U, then second column of L, then second row of U, and so on. And if you consider diagonal of L matrix to be 1, and then you have to start with first row of U and so on. Now, if the matrix is positive definite, then such decomposition is always possible, and the decomposition can be obtained very easily, not by hand. Hand calculation will be a bit tricky. Okay, and your aim is not to implement or find some technique to solve the system of equation by hand. You want to use computer to assist you. Okay, so I'll be stopping here. So decomposition is discussed today. In next class we will be complete the whole problem, and next we will be discussing LL transposition decomposition method. So that will be very similar to LU, only L into its transpose will be considered. So for that, matrix has to satisfy one more condition, that the coefficient matrix has to be symmetric. Then only that L into L transpose decomposition is possible. So first it has to be positive definite, and then along with that the matrix has to be symmetric. Then you will be able to write down A as L into L transpose, and there the calculation will be even smaller than this. Calculation will be less compared to LU. So those techniques will be discussed, and one or two examples will be solved in the next class. How to implement LU and LL transpose decomposition. So is it okay? I'll be stopping the discussion today. So any doubts, anybody?
No, sir.
Okay, okay. So remember, you can apply LU decomposition. So the sufficient condition matrix has to satisfy, it has to be positive definite. Now remember, that is not necessary. Even though the matrix is not positive definite, still sometime you may get LU decomposition. But it will be guaranteed that such decomposition will exist if the matrix is positive definite. So that is sufficient condition, not necessary. Okay. Okay, fine then. Okay, you may leave if no doubts are there.
Thank you, sir.
Okay, okay.